welcome to qiphyedu. Today I'll be looking at computer science, A2 level, paper 32, October-November 2022. Alright, let's start. Okay, so for the first question it says, normalized floating point numbers are stored in the computer system using 2's complement for both the mantissa and exponent, with 11 bits for the mantissa and 5 bits for the exponent. Write the largest positive 2's complement binary number that can be stored in this system. Okay, so positive 2's complement binary number. Therefore, what we need to do here is we need to identify the most significant bit. The most significant bit is this one for the mantissa and this one for the exponent. Because this bit, if you put a 1, that means that the number is a negative number. If you put a 0, the number is a positive number. Alright, same goes for the exponent. And then the exponent is used to calculate the point between the most significant bit and the second bit, all the way to the point between the whole number and also the numbers that are smaller than 1 are basically like 0.5 or 0.75, right? So in order to calculate the largest number from that, you need to move the point all the way to the far right, the most possible one basically. So in this case, the mantissa, the largest number for the mantissa would definitely be the most significant bit being 0 and all the bits on the right being 1, right? So something like this. And this is the same for the exponent. The most significant bit on the left will be 0 and all the numbers on the right being 1. Okay, so this is the answer. And B, it says calculate the denary value of the given binary floating point number. Show your working. Okay, so we are given this mantissa and we are given this exponent. What we need to do is calculate the exponent. This one is 2 power 0, then 2 power 1, we're not going to calculate that, and 2 power 2, and then 2 power 3, so this one will give us 9. Then for the mantissa, you need to remember that we have to calculate it by moving the point between the most significant bit and the second bit to the right. This one is 9, so we just have to move 9 times here. Okay, then we can start by changing the second bit from the right to 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, and 2 power 9. Okay, so we know that this one is 1 0 1 1 0 0 1 0 0 1.1. Then what we do here is we can just change it to positive form, which will be 0 1 0 0 1 1 0 1 1 0 1, and then here we can calculate directly by comparing it with the bit position I have on top. So this one will be 2 power of 2. Okay, this one 2 power 2, this one's 2 power this one is 2 power of 0, then this one is 2 power 1, 2 power 1 plus 2 power 2, then this one is 2 power 3, so we don't need to count that, and 2 power 4, then 2 power 5, then 2 power 6 we don't need to count, 2 power 7 we don't need to count, and then 2 power of 8, then plus 1 over 2, which is basically 1 over 2 power 1. Okay, so then what we'll get is 2 plus 4 plus 16 plus 32, then 2 power 8 would be 256 plus 0.5, and then we'll get 22, 32, we get 54, then we get 310.5, but you need to remember that this is a negative number, so you change it to negative, so that will be negative 310.5. Okay, so we just put it in the answer here, negative 310.5. So I'm just going to move this to the right. Right, and then C, state when underflow occurs in a binary floating point system. Underflow happens when the number itself is too small to be represented using the available system, using the available mantissa and exponent. So we just say that following a logical operation, the value is too small decline in the available system. Due to insufficient number of bits. Okay. Then question number 2. Lexical analysis and syntax analysis are stages in the compilation of program. Identify 2 other stages that take place during the compilation of program. That would be code generation, which is basically used to generate code, and optimization to basically allow the program, the code itself, to have to be able to run on devices with lower memory. So basically to fulfill more computers' memory requirements. Okay, B says outline the purpose of syntax analysis. It checks that the code matches the grammar of the language, syntax errors are reported, and the parse tree is produced. Okay. 3A, explain why a protocol is used in communication between computers. It's basically a standard for communication and allows 2 devices to have compatibility. So what we can write here is protocol. Protocol set a standard for communication. It enables 2 devices, or you can just say it enables compatibility between 2 devices, or you can just say between devices from different manufacturers. If 2 devices send data to each other using different protocols, it may result in failure to receive the data. Right. Then B, the TCP/IP protocol implementation can be used as a stack. Complete the diagram for the TCP/IP protocol stack. So first one is application layer, then second is transport layer, then it's your internet layer, network layer, or the skeleton network layer. And now we need to describe the purpose of the IMAP protocol. It's used to retrieve emails from a server, basically, used by email clients to retrieve email from a mail server. It keeps the server and client in sync. Okay. And 4A, a program is to manage regular flight details at an airport requires some user-defined data types. Write pseudocode statements to declare the enumerated data type aircraft to hold data about the types of aircraft used for flight. So just put type aircraft equals, and bracket, C300, C350, D242, E757, and X380. Bracket again. Then B, Write pseudocode statements to declare the compulsory data type flight to hold data about flights to a specific destination. This includes all the 4 things below, so just have to type, just put in type flight. You need to declare flight num or flight number as flight num as string, then declare destination. This will make it look better. Declare destination string, and then declare date of part as date, and then declare aircraft type. And this one already have the enumerated data type on top, which is aircraft, so we just have to declare aircraft type as aircraft, and then we end the type. So this will restrict aircraft type to only the specific values on top, C300, C350, D242, E757, all those, right? And C1, we need to write the pseudocode statement to set a variable for one record of the compulsory data type flight. So we need to declare one variable. So declare flight 1 as flight. Okay, so the flight 1 will be limited to everything on the top here, these 4 things. Alright. 2. Write pseudocode to store the details of the following flight in the variable you set up in part C1. Use the field names we created in part B. Okay, flight number, just now is flight num, so just put flight, C1 here is flight 1, so we just put flight 1 dot flight num. This one just put in inverted commas, this one you need 2 commas, this one is XA7A2. Close the brackets. Then flight 1 dot destination. And same thing again, just put Cambridge, closing commas. Then flight 1 dot date of depart. Date of depart. Okay, this one just put in 12/12/2022. Then flight 1, this one aircraft type. Then we just put in C350. Alright, so that's how we do for this one. Then 5, describe what is meant by virtual machine. It's basically emulation of computer hardware. Which allows guest operating systems to run using run alongside the host operating system. Okay, then benefit 1 is saves costs as additional hardware does not need to be purchased. Okay, second one, you can say increases, well, you can say that multiple operating systems can run on the same computer. Okay, then disadvantage is that it requires a lot of memory. Requires higher system resources, which result in higher costs. So basically just now we're contradicting, but then we can say that you save cost buying additional hardware, but at the same time you require higher system resources. So that in itself, right, would also make the computer much harder to maintain. So we should require or you could say that or we can remove the cost portion. We can say requires higher system resources because weaker system resources will result in poorer performance. And the second drawback is that you can say that cannot emulate some hardware. For example, if you have a computer that uses the x86-64 architecture, but you try to emulate an operating system that uses ARM64, this is not going to work. Okay. So the drawback here will be unable to emulate some hardware. Or you could even say that if you try to use a modern Windows computer, the one using x86-64, you try to emulate a computer using PowerPC from a very long time, like before this MacBooks uses the iBooks uses PowerPC, then it won't work, right? That's one. And 6a, state two differences between symmetric and asymmetric encryption. Symmetric uses only one key, whereas asymmetric encryption uses two. The symmetric key is used by everyone, whereas only one of the keys in asymmetric encryption which is the public key is available to everyone. Alright. And B, explain the process by which an organization may acquire its digital certificate. First of all, the organization requests a certificate from the certificate authority. And then second, they will send in their public key. And gather all the information required by the CA to obtain the certificate. Then the CA verifies the organization's identity and generates the certificate including the organizations Okay, so that's how you get your 5 marks. And 7, supervised learning and unsupervised learning are two categories of machine learning. Describe supervised learning and unsupervised learning. Supervised learning basically is you give it an input and the known output as well. So basically you can say allows data to be collected from previous experience. Known input and associated output. Are given, and then it is also able to predict future outcomes based on past data. Then for unsupervised learning, it is used to find all kinds of unknown patterns in data and only requires input to be given. If you want to be on the safe side, you can add one more. You can say it uses data is not trained on the right output. Okay, that's for this one. And then for 8, we need to draw a logic circuit for an SR flip-flop and label the input. So first one we put S, the second one we put R. Then we need to put 2 NAND gates, like so. Okay, and both of these NAND gates will connect to its respective outputs, which is Q and not Q. Then we need to link S and R to its respective NAND gate, like so. Then here what we do, we link like so, and this one we will link it to like that. So that's for this one. Then B, we need to state the purpose of flip-flop. We can say to store a single digit. Store a single bit, sorry. So just put to store a single bit. And then now we need to simplify the following expression using boolean algebra, including De Morgan's law. First of all, we can just copy and paste everything from the top. Okay, then we can remove, we can separate the top bar into 3 pieces like this. It's a bit unsymmetrical, but yeah, like this. And then we can remove the top 2 bars, like so. Okay, plus BD. For the second one, you need to change it to, instead of using dots, you need to use plus. So that's why I need to change it to that. Okay, and then now it's time for optimization. So we can just move not A out, this one is not B plus C. This one we need to change this to plus. Then this one is plus B dot D. Okay, and the answer would be this one. wrote down in front. And 9a, we need to write out the need for scheduling and process management. Allows more than one program or allows more than one task to be executed at once, at the same time. Also allows high priority jobs to be completed first. It also allows CPU to be busy all the time, which ensures that all processes are executed efficiently. Alright. Then B, describe these scheduling routines and identify a benefit for each one. So shortest job first, short jobs or short processes are executed first, and then followed by longer processes. Okay, which leads to an increased throughput. Then for round robin, each process is served by the CPU for a fixed time. So that starvation does not occur. Okay, then first come first serve is basically each process is executed in the order it is received, and starvation does not occur. Okay, so then 10a, define these object-oriented programming terms. Encapsulation is putting properties and methods inside a class. And then for getter is basically a method that's used to return the value of a property. Setter is basically a method to update the value of a property. Okay, hence the name setter and getter. Then B, a school has a program written using OOP to maintain its staff and student records. The object substitute teacher allows the details of the school substitute teachers to be stored. This includes their full name, telephone number, and whether or not they are in school today. For example, subname, telephone, in school. Complete the diagram for the object substitute teacher, including appropriate properties and their getters and setters. Okay, so now we need to declare this variable here, which is telephone. In this case, it's only numbers, but then you need to remember that 0, if there's 0 in front, then it has to be a string, because in integer, the 0 will be omitted in front. Then in school boolean, then we're done with that. Then we need to set the values on top. So here is set name, or we can say set subname, which is more complete. So it's name, string, then set school, set in school. Then we can just put status boolean. Then we can get subname, get telephone, and get in school. Alright, that's it for this one. And then 11, a simplified linked list is used to store the names of flowers in alphabetical order. It is implemented using two 1D arrays. Flower stores the names of the flowers, next pointer stores the pointer to the next flower name in the list. Head pointer indicates the index of the first flower name in the linked list. When the end of the linked list is reached, the next pointer has a value of 0. The following table shows the initial content of arrays. Alright. In A, it says several flower names have been deleted from the linked list. These are crossed out in the following table. And complete the table will show the new values of head pointer and next pointer and keep the remaining flower names in alphabetical order. Okay, so what we know here is that the head pointer is 6. So if you look at head pointer 6, it's Dahlia, and next pointer is 5. Here 6 is omitted and the next pointer is 5, so we can just directly move to 5. And then if you look at Daisy, the next pointer is 3, so we can just jump to 3. So you can write that here, but then head pointer we need to put 5 because 6 is now gone, 5 is a new head pointer. And then move to 3, then Foxglove will then go to 10, but 10 is removed, so we need to look at 10. 10's next pointer is 4, and 4 is available, so we can just directly put 4 in the next pointer, in the column of 3. And then after we jump to 4, it jumps to 9, 9 is available, so we can just jump to 9. Then Lily will jump to 8, 8 is available, so we can jump to that. And then Lupin will jump to 2, but 2 is unavailable, so let's look at the next pointer at 2, that will be 1, so we can just jump to 1. And then Rose will jump to 7, but 7, we can't jump to 7, so we can just directly end it by putting 0. Okay, so that's it for this one. And then B, we need to complete the pseudocode algorithm so that it achieves the following and apply to the arrays. The flower name is input, the linked list is search, in order for flower name. Okay, let's just do that first. So flower name is input, so we can just input flower name. Okay, then this one, if you look at the bottom, this is a while loop, so we can just say while pointer doesn't equal to 0. If the pointer equals to 0, then everything has ended already. Okay, then here if flower pointer, just look at third one. It says flower name is found and appropriate message output. If the flower name is not found, appropriate message output that has not been found, the algorithm terminates when the next pointer value is 0. Okay, so if flower pointer equals flower name, then found equals to pointer, pointer equals 0. Else, then we need to move on to the next pointer. Like for example, the pointer here, let's say flower is 3, like this for example. Then you go to 3, but then if it's not the name, then you'll go to 4. But in order to get to 4, you need to go to flower, you need to go to the next pointer in order to do so. Alright, so here what we do here is pointer, and then put next pointer. Because we know this is also a 1D array as shown in the top here. Flower is 1D, another one is one 1D array, and next pointer is another 1D array. So the numbers for the next pointer is stored under the next pointer array. So here we just put pointer, basically is equals to next pointer, pointer. Okay, and if and while, and then if pointer equals to if pointer equals to 0, then output flower found is found, else output flower not found. Okay, and that's done. And then C, you can say explain how you could improve the simplified linked list structure. So you realize that at the top right, it points directly to 0. So now what we want to do is we want to include a free list pointer. Okay, so that we will be able to use the unused space. So what you can do is to include a free list pointer to reuse the unused space. As a linked list. Of free space. Okay, so that's that. that one you can get 3 marks, but you only get 2 marks here, but it's okay. You can write more, it's better to write more. Okay, so then this is the end of this paper. I hope you guys find this video helpful. Do share this video out to other people who may need help with computer science A2 level. As always, I hope to see you guys again in the next video. Till then, this is qiphyedu. Goodbye.